Parts A and B of this problem ask us to find the resistance R and the readings in ammeters 2 through 5. Let's start by labeling some of the currents. I'll call the current through ammeter 1 and the resistance R I1. We'll call this one I2 and this one I3. Now we can apply Kirchhoff's loop rule to this loop, which I'll call number 1, summing the voltages around loop 1 and setting it equal to 0. Starting at the battery, we have 200 volts minus the voltage drop across the resistor, and that equals 0. We know the current I1 is 10 amps, so we can solve for the resistance R, finding that it equals 20 ohms. I'll record that over here. Let's draw another loop now. We'll call it loop 2, here in the middle. We can sum voltages around it, setting it equal to 0. Starting at the battery again, we have 160 volts minus the voltage drop across the 40 ohm resistor, moving in the direction of that current, setting that equal to 0. And that tells us that I2 equals 4 amps. I2 is the current through ammeter 2. Now that we're over here, we can also record I1. Let's draw a third loop over here and apply Kirchhoff's loop rule to it. Starting at the battery, we have 160 volts minus the voltage drop as we move with I3 through the 20 ohm resistor, setting that equal to 0, finding that I3 equals 8 amps. That gives us the current through ammeter 5. We can find the remaining 2 ammeter readings using Kirchhoff's node rule. Let's first look at this node. I'll draw a red current leaving it. We see that currents I1 and I2 enter it, so the red current leaving it must equal the sum of I1 and I2. That gives us 14 amps, which is then directed through ammeter 4. Last, we can apply Kirchhoff's node rule to the node right above this current that I'll indicate in red. We see that currents I2 and I3 leave that node, so the red current entering it must equal the sum of I2 and I3. We add those together and find that it equals 12 amps, which is the current through ammeter 3.